Alright, time to rant about why school is fucking stupid about how they rate you. So, this is a physics problem. You have one block, 5 kilograms, tied to another block, 3 kilograms. This is a hill going 30 degrees up. The rope is pulling the red block towards the blue block because the blue block has an acceleration over there because of that force. Now it could be that the blue block is falling down, maybe it's not going up, but the answer is going to be that they're actually going up. So whatever. The red block is getting pulled. Um, Now they ask you, what is the acceleration? This is how I would do the problem. I would say, well, there is a line right here. This would be the ground. There is one block right here tied to it doesn't matter. Another block. This one is 5 kg. This one is 3 kg. There is a force going like this at nope, that's not what I wanted to do. This is a force going at cos 15 times 42 Newton. And then there is another force right here on this block, but I'm just going to draw it over here because it's easier. And then there is another force like this, which is the gravitational force, so the mass of the blocks times the gravitational acceleration, which gives a force equals, let's just say like Fg equals, basically in this case it would be minus 3 kilograms times 9.8 meters per second squared. I can't write squared in paint. And then times sine of 30 degrees. If you were on a plane, the same force would be here, but it would be sine of 0 because it would be elevated by 0. But here we're up by 30, so yeah. This is basically, these are the two forces, and then all you do to find the acceleration is you pull out your fucking calculator. You look at the forces, which is easy as hell. You do 15. Can I do, okay, 15 cos times 42 minus 3 times 9.8 times 30 sine. Yeah, I could have typed 0.5, whatever. And then minus 14.7, enter. So this is the force. The resulting force is 25 newtons, like this. Oof. Yeah, let's just say that that's horizontal. What the hell? What is that? What is that? And then you just you write that down, or whatever it was. And then this is your force. And then to find your acceleration, you can say F equals ma. If the force is 25.87 Newton, equals the mass, which is 8 kg, times the acceleration. And then you just find acceleration equals, you divide by 8 on both sides, divide by 8. Then you find 3.2 meters per second squared. And then that's about it. When I did it, like when I wanted to do this, all the process I just did, took me about, I didn't have to explain it to myself or prove that it works or anything, so it took me about 30 seconds. How you have to do it though, to get 100%, you have to write the sigma of the force vectorial equals m times a being vectorial, and then you have to do this, Fy equals may, and then you would have sum vectorial f a vectorial also, fx equals max, sum of f vectorial a vectorial, and then you would have to say this is because of Newton's second law, F equals ma. And then you would also have to draw this. What the hell just happened? Okay. You would also have to draw this. Let's just do that because it's easier. And then you would have to put your little tips over here. Say X, Y. Then you would have to make another one over here. Oh, no, that's not right. Over there. Say that's a Y, let's say prime. That would be X prime. And then you would have to say for the block 1, F on, well actually yeah, that's kind of all the forces on the block 1, so you would have to forces on the block 1. Well, let's just say red forces, it's gonna be fine. And then you would say, you would have to then realize that there is a force right here, let's call it red T, and here there is a blue T. And then you would have to put your vectorials over there. Don't go too fast, you're gonna forget your vectorials. And then you would have to also put something like this. Say this is G. Say this is the normal going against the surface pushing the block upwards so that it doesn't just flow through the ground. Then you would also have to do this. Say this is G. Say this is N. You would have to do this. This is G. This is GX. This is GY. And then you would have to do GY equals, oh, I'm on cap. GY equals cos, well, minus cos, and you would have to put G vectorial, or, no, actually, if you put GY, you don't have to put vectorial, equals minus cos of 30 times 9.8 meters per second squared times 3 kilograms. And then you could calculate that, and then you would have to say gx equals basically all this, except here it's going to be sine. And then you would have to come back over here, red forces, there would be the sum of the forces, vectorial, equals g vectorial plus t vectorial plus n vectorial. And then you would have to say, you would have to literally come over here and say the rope is considered to be a perfect rope which doesn't weigh, I'm French, I don't know if it takes a T when you write it like that, anything, and doesn't extend. So, conclusion, T1 equals let's put it purple, damn, T2. And then you could say in black equals T, equals T. And then you could like come over here and do this. F y equals 0 equals basically n minus g. Sum of the forces in x equals ma equals, well, max equals, well, it's the same as ma, but whatever, equals ma, and then you would have to put your vectorials and all that shit, equals t, and then you would have to come over, well, actually, yeah, let's put all this in red. Then you would have to do the same for a blue. So you would come over here, you would have forces. Sum of the forces vectorial equals g plus t plus f plus n. This right here would be I kind of forgot to write it, I guess, but this would be the force that we would just call F. And then you would have to say F. Oh, yeah, let's go back to blue. What? Let's go back to blue. Sum of the forces in Y equals 0 equals normal minus gy. Sum of the forces in X equals ma equals um, there's the gx plus the t, that is the same t in the other one, plus the force, and then you would have to say um, tide, so A equals A equals A or something, and then you would have to come over here and say A equals T divided by M equals T divided by 5 kg. This is what we get for acceleration in this one. Then for the other one, you would have to say A equals gx, which we have, plus T plus F, which we have, divided by M, which is A equals minus sine 30 times 9.8 times 3 plus T plus 42 Newton. Yeah, I could have written, actually, yeah, Newton, times 42 Newton times cos of 15. And then you would have to compare the two equations, and then you would get, you would have to write it out. Should I just write it out? Whatever. I forgot to divide this, so let me just divide it by 3 kg, and then you would get 3 kg times T equals 5 kg times minus sine 30 times 9.8 times 3 Newton plus T. Actually, I should probably just write all the terms 5 kg times this separately. 5 kg times T plus 5 kg times 42 Newton times cos 15. And then you have compared the equations. And then I'm already out of fucking space. What if I drag all that over here? Because this is taking way too long because it's useless. And I found the answer in about 20 seconds. And our teacher didn't even say the right answer. He said it was like 1.998, but it was 2.008 because he didn't do it in one shot because he's too stupid, probably. And this shit is pissing me off because I shouldn't have failed my physics just because I can get the answer faster so that I don't have to do all this shit. Oh my god. And then you would come over here and put the two t's on the same side, and you would basically do minus 5 kg times t, so you would have minus 2 kg times t equals actually, yeah, I could 5 kg times 42 Newton times cos 15 minus that would be 29.4 Newton times, well, times minus 1 divided by 2. No, actually, I already did the minus. So divided by 2, so that would be just 14.7 Newton. Alright, and then can we just... and then you would find that... and then you would divide by this on both sides, actually. Let me just... drag this over here, destroy that. Draw a line like this. Then you would have, I'm gonna get a negative t. Is this shit normal? I'm gonna check my equation after to see if it makes sense. 5 times 42 times 15 cos. Yeah, actually I should have done this differently, but whatever, I already did it. Minus 5 times 14.7 divided by minus 2, minus 64. Oh my god, yeah, I think I messed up because there's just way too many steps to this shit. You get lost, you can just look at it and get the answer, and it's just easier for everybody. Where did I mess up? Now is I know I messed up because this makes no sense. Um, I said the acceleration is equal to t. Yep, that's right. So this is right. So this means that this is not right somewhere. Let's see. I can remove this. Nobody needs that. That's fine. Also, I know that. Okay, so I said acceleration equals minus plus that. It seems fine. See, I can't even find my answer. Oh, it's probably when I compared the two equations or something. I did times 3 kg times 5 kg minus sine of that 5 kg. Oh my god. Oh, it's because I did plus t. Yep, it's just this. Oh my. And you have to be so careful when you're doing all this, and it's just harder than actually thinking. It just takes out the thinking out of everything. Like, who wants that? You want to be able to look at it. If you're able to give the answer, good, you get 100%. But no, it's not how it works. So you would have actually divided by, it wouldn't be minus 2, it would be 8. Um, right here. What am I doing? 8. I should probably just maybe do this. Can I drag it over? There we go. And then you would do this times minus 2 divided by 8. And you would find t equals 16 something Newton, 16.2 or something. Let's just say 16.168 Newton. And then if you do 16.168 right here, 16.168 Newton divided by 8 kg, because this is like if you replace, what am I doing? It's divided by, it's times 5 kg. It's divided by 5 kg, not 8. What am I saying? You find this. Because if you replace it in this equation, you get A equals T divided by 5 kg, so tension divided by 5 kg, and which is what I did. And you get 3.22233. Oh yeah, I did say that our teacher got the wrong answer. He didn't use the same things here. I didn't remember exactly what we did, so I typed different but values, but he did actually get it wrong. I wasn't lying about that. I mean, why correct your answer if it's still gonna be off by, it was off by 1%, but don't correct yourself if you're still gonna be off. I mean, fuck. So then you get A equals 3.223. Was it that? 223, 2336 meters per second squared. How long did that take? Like 15 minutes? Oh my god. That is terrible. Like, this is literally why I failed my physics, because this shit, I looked at it after, okay, I did it properly, I found the answer, and then I looked at the problem, and I was like, why am I even doing this? Why am I even doing this? Why can't I just take out my calculator, look at the problem. There's a force over here that's equals to 42 times 15 cos. There's a force like this. There's another force equal to this, and then this is the resulting force, and then you just divide that by what the hell happened? Did I subtract? I think I added them together because that's too high. Wow. 42 times 15 cos. You have to be smart enough to realize when you do something wrong. Oh, it's because I did minus minus, so I'm just gonna add cos of 30, sine of 30. Actually, I'm just gonna type minus 1 divided by 2 times what? Okay, I think hopefully this is negative. Should be. I mean, I don't understand how it wouldn't be. This is the resulting force, then you divide that by 8, and you get this. And this is the exact answer. This is the exact answer. Like, how hard was that? All you have to do is look at the fucking problem. There's one force like this, you just fucking type it, and then you remove the other force, the gravitational force, which is equal to, of course, sine 30, which is 0.5, times the gravitational acceleration times the mass, and then this is the resulting force. Then when you have your resulting force, F equals ma, A equals F divided by m, F divided by m equals this number you see right here divided by 8 kg equals 3.233610588 meters per second squared. And it's just like, I don't understand why they're making us do all this shit when you can literally just see the problem like this. You have this, then you have this, and then you have a force over here and a force over here, like that. And then you have 42 Newton times cos 15, and here you have 9.8 times 3 times sine 30, and then you add them up, and then this is 8 kg, and then you get your answer. But you're not allowed to do that because you didn't write the equation. Oh my god, you didn't write all the sum with the vectorial shit. Dude, really? Really? Like, I got 53% in my first physics exam last session. It wasn't even about that. I don't even understand why in high school we did all this and we're just redoing it right now. Cause, I mean, this is literally stupid. I could have done this shit like 5 years ago and got the right answer just by looking at the problem, but no, you can't look at the problem. You have to put your fucking face into your book and not look around, not do anything. Look at the formula, type it exactly the way they want. Not allowed to think, you're just allowed to write. And then once you're done writing everything in order, then you're allowed to use your calculator to get the final answer that you write down. And then if it doesn't have three numbers right here, oh, there's too many numbers. I have to remove this, otherwise I'm gonna lose points. If it's not 3 numbers, it's too precise. Even if you did it in one go on your calculator and you got the exact answer, no, it's too precise. 3 numbers or you're gonna die. We're gonna remove you 5%. Oh yeah, and if you just give us the answer and you don't say how you got it, that's 0%. That makes a lot of fucking sense, right? Right? You give us the answer but 0%, yeah, that makes a lot of fucking sense. 24 minutes. This problem took me 20 seconds. Fuck.